Imagine a massive asteroid streaking through Earth's atmosphere, slamming into the surface with unimaginable force. This isn't science fiction. It's a terrifying possibility that scientists take very seriously today. The Earth has been struck by asteroids before, with catastrophic consequences that reshaped life as we know it. One of the most infamous impacts happened 66 million years ago, triggering the extinction of the dinosaurs. That asteroid crashed into what is now Mexico, creating a crater over 90 miles wide and 12 miles deep. The impact vaporized rock instantly and blasted dust, ash and sulfur high into Earth's upper atmosphere. These particles formed a thick global cloud that blocked sunlight and cooled the planet dramatically. Temperatures plummeted, photosynthesis halted, and ecosystems collapsed almost overnight across the globe. This event led to what some scientists call an impact winter, a type of instant mini ice age. So the question isn't just, can it happen again, but whether it would cause another deep freeze. Asteroids still lurk in the solar system, some of them large enough to pose real global threats. NASA tracks over 25,000 near-Earth objects, with hundreds classified as potentially hazardous based on their orbits. Even a smaller asteroid, just 1 kilometer wide, could have climate-altering effects on a planetary scale. If it struck land, the resulting debris cloud would likely reach the stratosphere within hours. The higher it goes, the longer it stays suspended, increasing the chances of sunlight being blocked worldwide. Without sunlight, global temperatures could drop significantly, disrupting agriculture and triggering widespread ecological stress. Ocean currents could stall, jet streams would shift, and entire weather systems could collapse or behave erratically. Snowfall would increase in some regions, while droughts would deepen elsewhere due to stalled atmospheric circulation. This kind of event doesn't just cool the Earth, it scrambles the entire climate machine. But not every asteroid would cause an ice age. Its size, speed, and impact location all matter. If it hits water instead of land, much of the energy might be absorbed without launching atmospheric dust. Still, an ocean strike could trigger massive steam clouds and tsunamis that change coastal climates for decades. The bigger threat for an ice age, though, comes from ejecta, rock and particles blasted into space. Some of this debris would re-enter the atmosphere, heating up and igniting wildfires across entire continents. These wildfires pump additional carbon and soot into the sky, thickening the already sun-blocking cloud layer. The chain reaction worsens with every additional degree lost and every ecosystem destabilized. Within days, the skies could turn dark gray, daytime might feel like twilight, and crops would begin dying. According to some simulations, global temperatures could fall by 10 to 20 degrees Celsius for several years. These drops mirror the conditions of known ice ages, long-term periods of intense cold across the planet. The most recent ice age ended about 11,700 years ago, and its effects are still visible in landscapes today. Glaciers carved valleys, left behind massive boulders, and shaped entire ecosystems during that frozen era. If an asteroid triggered a new one, we could see glaciers return within a generation in some regions. Northern Europe, Canada, and parts of Asia could become nearly uninhabitable without modern heating infrastructure. The global food supply would be in crisis, especially in tropical regions hit hardest by temperature swings. This isn't just a climate issue, it's a civilization-level risk with economic, political, and humanitarian consequences. NASA, ESA, and other space agencies are actively working on ways to detect and deflect potential impactors. The DART mission, launched by NASA, recently proved that we can alter an asteroid's path using kinetic impact. In 2022, it slammed into a moonlet and shifted its orbit, marking humanity's first planetary defense test. But warning time is crucial. The more time we have, the more options we have to act. Unfortunately, many space rocks remain undetected until they're uncomfortably close to Earth. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, injuring 1,500 people and damaging thousands of buildings. It wasn't even on astronomers' radar before entering Earth's atmosphere, a sobering reminder of our vulnerability. If a much larger object were detected too late, we might be unable to stop it from hitting us. Even if the asteroid doesn't cause an ice age, its initial destruction would still be unprecedented. Billions of animals could die in the first wave due to habitat loss, temperature collapse, and food scarcity. Migratory birds would lose their seasonal cues. Marine life would be disturbed by altered ocean chemistry and light loss. Insects, crucial for pollination, could decline rapidly, further stressing the food chain from bottom to top. Animals in colder climates might initially benefit, but as conditions worsen, even they would face deadly extremes. Evolution happens slowly, and such a rapid planetary shift wouldn't allow enough time for adaptation. Species unable to migrate or hibernate might face extinction within months of the impact. Zoos, sanctuaries, and conservation parks would become last lines of defense for many endangered animals. Human intervention might keep certain species alive artificially, but not indefinitely in a collapsing environment. Ecosystems would unravel, starting with the most fragile wetlands, coral reefs, and alpine zones. Rewilding efforts and animal conservation programs would struggle as biodiversity declines and funding dries up. Climate refugees wouldn't just be human. Animals would desperately seek new homes across altered landscapes. Territorial conflict between species could increase as predators and prey collide in shrinking habitable zones. Diseases would also spread rapidly in these stressed populations, possibly jumping between species more often. In the long term, new ecosystems would stabilize, but not without massive losses first. Scientists believe it could take thousands of years for climate and ecosystems to rebalance after such an event. The fossil record shows us that life finds a way, but it often takes time and radical change. Earth has survived multiple extinction-level impacts, but the cost each time has been astronomical in biological terms. Some researchers speculate that we are currently overdue for another significant impact event. The odds of a large asteroid hitting Earth are low annually, but not zero over thousands of years. Space-based observatories like NEOWISE help scan the sky for threats, but they don't cover the whole sky. That's why space agencies are calling for more funding to expand detection and defense systems. Preparing for an asteroid strike is much cheaper than rebuilding civilization after one. Experts estimate that even a medium-sized impact could cause trillions of dollars in damage globally. That's not counting the unquantifiable loss of biodiversity, ecosystems, and stable climate conditions. Mitigating the threat requires global cooperation, early warning systems, and strong investment in space science. It's one of the few truly planetary threats we all share, regardless of borders or politics. While we can't prevent all disasters, this is one we can actually see coming if we look. And if we act in time, we may be able to stop the next ice age before it begins. In the meantime, we keep learning from the past, studying craters, fossils, and climate records left behind. These clues help us understand what happens when the Earth suddenly tilts into survival mode. It's a reminder of nature's power and of the fragile balance that makes life on Earth possible.